In this lesson, we are continuing our discussion of binomial distributions, but what we're going to be talking about is how you can use a built-in function on your calculator to calculate these binomial distributions. And after doing the last homework assignment where you had to do a lot of them by hand, you'll probably be relieved to see this. So we're going to do this in the context of a problem that I'll show you how to use your graphing calculator. And we'll come back to these in a little bit within one of these problems, and I'll take out a calculator and show you where to push the buttons. But basically we have two built-in functions. One of them is called binom PDF, which means probability distribution function. And that's going to help us find the probability that x is equal to some particular number. So remember, x is our random variable. And it's going to, if it's following a binomial distribution with n trials and probability of success p, then we can use this binom PDF to find the probability that x will equal a certain number. There's also something called a binom cumulative distribution function, which will add up all the probabilities up through a particular value. So if I wanted to find the probability that x is less than or equal to some value k, then I would use binom CDF. And again, this is the number of trials, this is the probability of success, this is going to be your value of k that comes from here. So we'll see that on your calculator in just a moment. All right, but let's jump into an example. So this says, suppose that a biased coin is constructed so that the probability of tossing a head is 3/4. So in other words, it's weighted in some way. A normal coin, when you flip it, you have equal probability of getting a head or a tail, but this is weighted in some way so that the head comes up more often. So this says the coin's going to be tossed 2 times, and the number of heads is going to be counted. And we're going to let the random variable x be the number of heads. So the first thing you're asked to do is to write the sample space for the random variable. So the sample space, remember, is what are the possible outcomes. If x is counting the number of heads and I'm tossing the coin twice, then I might get 0 heads, or I might get 1 head, or I might get 2 heads. So that's our sample space, the list of outcomes. List of possible outcomes. Okay, is what we mean by sample space. Now it says, write the statement of distribution for the experiment. Well, first of all, I do want you to notice that this is a binomial distribution. So remember that the first thing that we need to look for is that there are possibly 2 outcomes, success or failure. And so we either get a head or not a head, right? So we get a tail, I guess. So 2 outcomes. We have a set number of trials, or a fixed number of trials. We have 2 trials. And the probability of success stays the same. The probability of getting a head is 3/4. Okay? And then we defined our random variable x to be the probability of getting a head, of getting a success. So this is a binomial distribution, so we can say that x follows a binomial distribution with 2 trials and probability of success 0.75, or 3/4. And then finally we want the probability formula for this experiment. So remember in general that for a binomial distribution, the probability that x is equal to x is equal to n choose r times p to the r times 1 minus p to the n minus r. So for this particular experiment, it's going to be the probability that x is equal to x is going to be 2 choose r, because 2 is the number of trials, and then p is the probability of success, which is 0.75 to the r, and then 1 minus 0.75 is 0.25 to the n minus r, which is 2 minus r. And we're going to be doing these calculations with your calculator, with the built-in function on your calculator, but at least for one problem, we're just going to confirm the answer using that formula, just so you can believe that it works. Okay, the next one says create a probability distribution table for the experiment. So remember that the way that that works is you have your x values here, and then you have the probability that x will equal any of those x values. So our x values here, we're going back to the sample space. We could get 0 heads, we could get 1 head, we could get 2 heads. So now this is where we're going to use your calculator for this, and we're going to use this built-in binom PDF, because we want to know right now, if I'm going to fill each of these in, what's the probability that x equals 0, what's the probability that x is equal to 1, and what's the probability that x is equal to 2. And again, we could put these values 0, 1, and 2 up here in the formula for actually, as I'm looking at this, this should be either an R, or we could change these to X's. But those need to match. So the probability that X is equal to 0, we would put in, so again, this should be R, I guess, if we do it that way. The probability that X is equal to 0, we're going to sub 0 in for each of these, or we would sub 1 in for each of these to get the probability that X is equal to 1. But we're going to use this binom PDF. So binom probability distribution function, and we have to put in 3 parameters. We have to put in n, which is the number of trials, p, which is the probability of success, and then our value that we have here. So we're going to do 2 trials, probability of success is 0.75, and we want to do this for 0. So if you have an older calculator, this is literally what you're going to be typing in. If you have a newer calculator, it will ask you for the trials, it will ask you for P, the probability of success, and then it'll ask you for the X value. So that's what we're going to put in for those values. So I'm going to stop now. We're going to do these on the calculator, and then we'll come back and put them into our table.